Hello guys, welcome back to Soulsky platform and I am Gaurav with you. So today in this video we are going to continue our C++ language series and we are talking about the basic things of C++. So let's continue this. Let's go to our notes. So what we did some basic things in our last video like about data types and how to naming of variables, okay, and about some storage, okay, how a number is stored, like that. So in today's video, let's see what we will do. Okay, so the first thing which is written here, that if we want to store big integral values in character data type, then what will happen? This is the question. So what will happen? Let's see what will happen. Before that, let us see some basic things. Okay. So in integer type data type, okay, in integer type there is 4 byte storage in memory. It means 32 bit. Okay. And for character type there is 1 byte storage in memory. It means 8 bits. So obviously in case of the amount of storage in case of character type data, this will be obviously less than the amount of storage in case of integer type data. Okay, because the storage here is only 8 bits, means 1 byte. Only 8 bit means 1 byte. And in this case, in case of integer type, the amount of storage is 32 bit, means 4 byte. Okay, so obviously 4 byte is greater than 1 byte. If we, okay, so now the maximum value which integer type data storage can store is 2 to the power 32 minus 1, and this value is in the format of decimal. Okay, this is in decimal format, and minimum value it can store 0. Okay, in case of character type data type, or character in a character type in a variable with character data type, uh, the memory can store in this case maximum value of 2 to the power 8. Okay, focus on it. The power in power of 2 is the number of bit in it. Okay, in this case also 2 to the power 32. 32 is the number of bits in this data type. Okay, so this is the maximum value, I mean decimal value, which a character type data can store. Okay, and minimum value of 0 in both cases. So let me erase this all at first. Let me erase this. Okay. Okay, let's start. There is a problem, I think. Okay, so let's go to the next thing. Okay, now if we want to store a number means decimal value. Okay, if we sorry, decimal, yes, decimal actually. If we want to store a decimal value, decimal integer value, the size of which is greater than the amount of size which a character type can store. Okay, here what in simple sentence, what we are doing here, we are storing a decimal value in a character type storage, but the size of this decimal value, integral value, is greater than the storage of character type. Okay, then what will happen? Okay, this is the case on which we will discuss now. So, if we divide this part, the part of the integer type data type, then this will be in 4 parts of 4 bytes. Okay, in this part 8 values can be stored, in this part 8 values, in this part 8 values, and in this part 8 values. Okay, last part. But in case of a single character type, there will be only the last part. Okay, only the last part is the size of the memory in case of a character type. So how many bits can be stored? 8 bits values. Okay, last 8 bit values can be stored. Okay, so how we can store this 32 bit in a 8 bit? We cannot store. What will happen if we convert this number, okay, this decimal value in binary format, means 0, 0 and 1 format. If we convert this to 0 and 1 format and store it in the integer type storage, then there will be like 0 0 1 2, sorry, 2 will not be there, 0 0 1 0 1 0, like that. Okay, there will be every places will be stored with this value. Okay, but when we storing this in character type, then all places values will be cancelled except the last box. Okay, the zeros and ones, okay, will be there in the last box, and these zeros and ones will be stored as it is in this box of character type memory. Okay, and then if we convert this 01 form to decimal value, then this decimal value means simple number 1 2 6 5, like that. Okay, if we convert this 01 format to decimal format, then we will get some decimal values, like example, as an example, 64 in this case, and it will be printed. Okay, if it is a character type output, then it will be then at the rate, which is the ASCII character in this case of 64, will be printed. Okay, so let us go to the code editor and see it. Okay, I have written this code here. Let me write it again. So let me write the basic structure of C++ programming. Has include IOStream is the data type, sorry, header file. Okay, and after that using namespace standard type. After that int main, and okay. Now what will be the data type? Character type, and here we want to store the value of 1 2 3 4 5 6 integer type. So let the variable name be ch, and here we are writing 1 2 3 4 5 6. Okay, now we have to check by outputting or printing this, that if this value, this whole value is stored. Okay, so let's output it cout, and after that variable name, after that endl. Okay, let's run the program. Let me clear this. Okay, if we run the program, what will happen? Let's see if the 1 2 3 4 5 6 is stored. No, the at the rate value is stored here. Okay, why at the rate value is stored? Because if we convert this 1 2 3 4 5 6 to binary format, okay, let us convert it. Okay, decimal to binary. So if we convert it, then you can say this is the binary, or you can say this is, okay, this is the binary value or binary format of this 1 2 3 4 5 6 number. Okay, and what is actually outputting? At the rate. Okay, at the rate is the output, or it is printing. Okay, so let us go to the ASCII table. What is the decimal type value for at the rate? 64. You can see here 64, and character is at the rate. Okay, this is 64. So actually 64 is printed. Okay, let us consider 64 is printed, and let's go to the Google Chrome. 64 is what? 64 decimal value printed. We inputted 1 2 3 4 5 6 this decimal value, but 64 is stored and it is printed. But why? I have told you the last box only will be printed. Okay, you can see here 1 2 3 4 5 6 7 8. Okay, this is the first box. After that, 1 2 3 4 5 6 7 8. Second box done. 1 2 3 4 5 6 7 8. Third box. Okay, 8 bit. Every box is of 8 bit. Last box, 1 2 3 4 5 6 7 8. Okay. This is the last box, and this is actually printed. Okay, this is actually the binary format of 64. Let us check if it is the binary format of 64 or not. What is the number? 0 1 and then 1 2 3 4 5 6. Okay, 6 values, I mean 6 zeros after 1, and before that all will be zeros. Okay, 1 2 3 4 5 6. Yeah, 6 1 and after that 6 zeros. Let us check. We inputted 1 2 3 4 5 6 and 64 is printed. Convert it. Okay, this is printed. This is actually printed. Okay, so 1 1 2 3 4 5 6 zeros and 1, and everything is 0 before that. So this the value is printed, only the last. Okay, and the decimal value for this binary format is 64, which is printed in the form of character. Okay, because the data type was character, so that's why at the rate is printed. 64 is stored. Okay, and 64 is converted uh, to a character, which we can see from this ASCII table that 64 is the decimal value, and character for it is at the rate. Okay, so I think this is clear to you. Okay, let's see what is the next thing written here. Okay, so here is the flow of the program. First 1 2 3 3 4 5 6 we inputted, then it is converted to 0 1 format. Okay, then stored in int type, actually not stored. Okay, int type, but fully not stored. It is actually int type. Okay, it can be stored in int type, but it is stored in character. We are forcefully storing it in character type. This is not int type, we are forcefully storing it in character type. Then fully not stored, only the last box is stored. After that only the last byte goes to the cache memory. Okay, last byte means last 8 bit. Okay. Okay, I think this is clear to you. After that, next topic is how negative numbers are stored. Okay, so the basic thing about negative number storing is if number is positive, then first bit is 0, means like 0, after that 0 1 2 3 4 like that. Okay, and if it is negative, then the first bit is 1, means after that another 0 1 2 3. Sorry, I mean not 3, only 0 1 will be in binary format. So yeah, in case of binary format, the first bit will be 0. If there is, let's say, if there is 32 bits, okay, then there will be 4 boxes, and here will be 8 bit, here 8, here 8, and in the last 8. So in this 8 bit storage, there also will be divisions, and in these divisions, in first division or first box, if there is 0 stored, then the whole number which is stored in this memory is a positive number. If there is 1 stored instead of 0, then the whole number 1 is stored, then the whole number will be a negative number. Okay, keep in mind. After that, negative number like -5, how to store? Okay, Okay, ignore negative sign at first. Okay, now the number is 5 for us. Now the number is 5 for us. Now convert into binary representation. So what is the binary representation for 5? If we store the 5 in a integer type data type, okay, if we store it in integer type, then all zeros and the last four bits are last 3 bits are 1 0 and 1. It will be stored like that. Okay, it means amid of among of 32 bits, the last 3 bits is 101. Why? Because what is the binary value of 5? Yeah, this is the 5. So the binary value you can see 101 0101. Okay, 0101. So the last 4 places will be stored with 0101, and before that all places will be stored with zeros. Okay, after that take 2's complement and store it. How we can take 2's complement? Before 2's complement we have to do 1's complement. So for 1's complement just convert 0 to 1 and 1 to 0. Now 0 to, if we convert it, then I told you that before that, before 0101, all spaces will be stored with what? Zeros. So if we do 1's complement, then all zeros will be converted to 1. So for that we have written it here that 1 this. Okay, and here this 0 also will be converted to 1, so we have written it to 1. One will, here is 1 and 1 will be converted to 0. Likewise the last 2 bits also. Okay, 0 is converted to 1 and 1 is converted to 0. After that if we do 2's complement, then we have to simply add 1 with it. Okay, so if we add 1, then 0 and 1 1. Okay, actually the adding process is some different, but when it will be required I will tell you about the 1's complement and 2's complement mathematics. Okay, 0 and 1 is 1, and simply the before that everything will remain same. So in this result, if we focus on the last digit, okay, it is 1, and I told you that if the last it means the first bit is 1, then it is a negative number. It is representing that it is a negative number. Okay, in this way the number is stored. Okay, so what is the steps? 5, at first ignore the negative sign. Okay, after that we have to represent or convert it to the decimal format, means 10 format. Okay, and after that we have to do the 1's complement, simply convert 0 to 1 and 1 to 0, and after that 2's complement by adding 1 to it. Okay, now we will get this negative number stored in our memory. How to print and display this negative number now? So for printing or displaying this, so actually this is the number which is actually stored in our memory. Now we have to display it. Okay, how we can display it? Simply do further do the 1's complement for it, convert 1 to 0, convert all 1 to 0 and zeros to 1. So 0 1, this. Now do 2's complement further, means we are adding 1 to it further. Okay, 1. If we add this, then this will be converted to the initial number. Okay, means 101, and this all are 0 before that. Okay, so yeah, this is converted to 5. Now it will print -5. Okay, this is not so important, just telling because yes, it can be used in some programs. We will see definitely, but for now just see how is the process is going. Okay, okay, let me see what we can do now. Okay, so there is many things, but this is not important for us. Like I can show you here. Uh, yeah, so this is the range actually, the range before and the range after. Okay, here we are using two representation. Okay, for after two is complete and before that. So this is not so important for you for now. Okay, let's start with operators. Percent. Okay, so what these operators will do? So operators, percentage is a operator which is called as modulus operator. Okay, so what it actually outputs? It actually outputs the remainder. And example after that, this operator. Okay, divide operator. So what it will do, if we write 2 by 5, then what it will do? It will just divide and give us the output. Like let me give some example. Okay, let's go to the code editor. Here, if I make a new file like operators dot operators.cpp. Okay, operators.cpp. So here we can simply write the basic structure has include iostream. After that, using namespace standard. Okay, after that, into main. Okay, now what is operators? So let a variable be int. Okay, int result equal to something. Okay, we will write it later, but before that let me write the output format. So what we will do, c out, and after that we will output the result. Okay, endl. Let's see what will happen. So in result, if we write 5 percentage of 2, then let's output it. Okay, though, so the output is 1. Why 1? Because when we divide 5 with 2, then 2 2s are 4 and the remainder is 1. Let me write another number. Okay, like 7 8, what we can do, like here write 7 and here 4. Let's see. We are expecting the remainder to be what? 3. Let's see. Yes, the remainder is 3. So actually this percentage operator is outputting the remainder. Now, if we use the divide operator, then what will happen? 2 and then here is 4. Okay. Now let's output it. Okay, the output is 2 because okay, this is actually dividing it like 2 to the 4. Remainder is 0 and it is divided by 2. So yes, this is outputting it. After that, if we write it 6, then what will be outputted? 3. Okay, because 3 to the 6. Nice. After that, if I write it as 5, then what will happen? What you expect? Still 2, but we are expecting 2.5 because 2 into 2.5 equal to 5. So let me change this data type and see what will happen. Now this is also 2, but why? Let me change it here also. 5 point this, and after that output. Now this is 2.5. But why? Because whenever we are wanting to output a floating type, because there is a floating type value, so whenever we want to print a floating value or accurate value, then we have to make this data type as float, and one of the variable or the both, okay, we can make both or one of the, okay, as floating value. So that's why I write it as floating type. So if I remain it same 5 as 7, then write 2.0, then what will happen? Let me see. Still 2.5. I told you that we have to make one of this as floating value. If we write it here as we make it both floating type, then the output is also like that. So if we store the values 5 and 2 in a floating type data previously, then the output will be also same. I think so. Let me see. Okay. Float A equal to 5, then float B equal to 2. Okay. And let us output A divide operator B. Okay. Now let's see the output. Output is still 2.5. So if we declare these numbers in uh, different variables, then we need not to write 5.0, okay, point, we need not to write point separately. This will be already stored with a, like, in floating format. Okay, like if we output now this A and B, you can see 5 is converted to 5.0 and 2 is converted to 2.0, means floating type. So if we see out this A and B, A, and then a space, after that B, okay, then, okay, let me give a endl also, endl, nice. If we run this program now, yes, this is actually not 5.0 and 2.0, but it is stored in a floating type. So during running the program, it will definitely convert it to floating type data. Okay. So these are the basic things. Let's go to the notes. Okay, there is also these operators like plus, minus, and star is for multiplying. Okay, these are some basic operators. Relational operators for checking. Okay, if A is equal to B, so if we want to check it, we can write it. Okay, if A is greater than B, if A is less than B, or greater than equal to, less than equal to, this is the not equal to sign. Okay, remember it. Uh, so this is the program, like int A equal to 2. If we store this, after that bool first equal to this and first, okay, equal to, this will check actually. And why we are using bool operator? Because bool operator is used for checking yes or no, means true or false. Okay, let us check it. If we write it as bool, means the output will be yes or no. Okay, means true or false. And we are actually, these are the checking operator, means relational operator. Okay, let us check it. Bool check equal to what? Equal to A equal to B. Let us check it. Okay, let me give a bracket. Let's output it, see out, and check. It will not output this A equal to B. Rather, it will output if true or false. Okay, it can output also 1 or 0. Handle. Okay. If we run this program, yeah, 0 is printed. Why 0 is printed? Because the answer is no. A is not equal to B. Because 5 is not equal to 2. If we change it to A is not equal to, just add it exclamatory sign here. And if we run the program, okay, the output is 1. Why 1? Because yes, A is not equal to B simply. And if we check it, like if A is greater than equal to B, okay, greater than equal to means what? Not equal to and greater than. It means equal to or greater than. Okay. So in this case, greater than this condition is applicable. So the output is 1. Yes, this is actually greater than. Not equal to, but it is greater than. Okay. After that, if we check for less than sign also, this will, let us check it. Let me clear it. Okay, so output is 0 because A is not less than equal to B. Okay, simple things. After that, remember it, we are using Boolean operators. We cannot use here int operator. Okay, because we are outputting actually true or false, means 1 or 0. Let's go to our notes. Okay, these are some relational operators. Then assignment operator, which we are actually using in equal to sign everywhere. Logical operators, okay, and this will actually use this in when we will learn about for loops, okay, different type of while loops and also conditional statement. We will use this, just keep in mind for now. Okay, this not operator, what it will do, make true false and false true. Okay, it will make true to false and false to true. Okay, so what will happen, let's go. If I write it 1 and if we write it as a not of 1 and change it as integer type. Okay, now if we output this, what will happen? 0 is printed because the not of 1 means now when we have written the value as 1, this is true, but in output we are writing not of check variable and the value of check is 1, means true. So not of true is false, and for false always 0 is outputted. Okay, if we write it write here another values, it will be also considered as true value. Okay, 0 is also printed. If we write 0, then what will happen? Then 1 will be printed. You can see here 1 is printed. If we write nothing, then let's see what will happen. Nothing will happen. Okay, so this is some basic things about this operator. After that, okay, we will discuss about bitwise operator later when it will be needed. Okay, so for today's video, this was our content, and we will definitely continue from the next video with some another topics. Till then, keep revising the all things and keep it in your mind. Okay, so if you like the video, don't forget to subscribe our channel and share it with your friends also. Okay, thank you for watching till the end. Take care and goodbye.